Okay. So I'm gonna get started. So welcome everybody. This is the second workshop in the ACM Hack Tooling series. We're going to be going over Git today, which is probably like one of the top topics that inspired this series. So I'm pretty excited about that. Let me quickly fix a technical bug. Okay, so here are a few links. If one of the mentors wouldn't mind just dropping these in the chat, I would heavily appreciate that. So we have some slides, links to slides. We have the README, which kind of will go, I'll kind of be going along with the README. And then we have the ACM membership portal, which is the same as it's always been. You can get like points for coming to different events, and the code for that is on this slide. So I'm going to leave this up for a few, like a little less than a minute. And then, okay. So I guess the first question is if we're going to be talking about Git, we should probably talk about what Git is. So we call, what is? Oh, okay. So the point thing is like usually like kind of greater, like ACM does like prizes for who has like the most points by the end of the quarter, I think. Or I don't know if it's a quarter or a year. I kind of forget.
It's quarter.
Yeah. Okay, so about Git. It's what we call a version control software. And effectively, the main point of Git is that it takes like snapshots of your code as you work on it. So the point of this is it like kind of tracks your progress of like your progress and your team's progress as you're working on your project. And effectively, it does this in like a graph. And you can kind of think of this like a timeline. So in this picture, let's see if I can grab like a pointer or something. Right here, in this picture here, like if time went from like left to right, you kind of see the progression represented by each like circle. And then you can see like it branches off, and you'll go into that. But the main point to take home is that what Git is for is to track the progress of your program, and to kind of like enable like a kind of like collaboration with other people, as well as a little bit of robustness in like if something goes wrong or something gets deleted, you can recover it. So this is kind of a similar kind of thing. Well, why would we use version control? And effectively, I always found that there are two main points. It keeps a history of your code. So this involves like kind of at each circle from the graph I showed you above, we have like what changed, who changed it, when was this thing changed, and then kind of with that information, you can undo like changes that maybe you didn't want to happen. And then additionally, you can kind of feel more secure about accidentally deleting something. So that's kind of the power of this sort of timeline of your project that Git provides you. Additionally, it helps enable you to collaborate with others. So because Git keeps track of all of your progress like this, and it's capable of some pretty useful operations that we'll go over later, it helps us to work on one project at the same time as many, many, many other people. And that's super powerful. So before we move on, one kind of misconception that I'd like to dispel is that is the difference between Git and GitHub. So a lot of people, you hear of Git and you hear of GitHub, and sometimes people kind of meld these two ideas together. And it's important that we separate them because they are very different things. So when I say Git, I want you to think that like this is version control. This is what keeps track of all of like my project history. This is like where like you like use like commits and all of that kind of jargon that we'll talk about. Where GitHub, you can kind of think of it like Google Drive for code. It is a cloud storage kind of service that you can use to put Git repositories onto. So just make sure you keep that in mind when we're talking about the two. Okay, so I guess the first thing is like let's talk about like the basics of Git. Okay, so the first thing I want to talk about is probably one of the most useful Git commands because it's very helpful, and that is Git Status. So effectively what it's going to do is it shows the kind of the differences between like the last time you like, quote unquote saved, and we'll talk about this more, but the kind of last time you made a commit to Git and your current files. And we'll get experience with this later, but it kind of shows you like, what are you like allowed to do at this point? It's how have your files changed so far from the last time that you made a commit? And this kind of seems like lame. You're like, well, Tim, why are you saying this is the most useful command? Is because of an additional point, which is Git Status drastically reduces the number of commands you have to memorize. I was enlightened by the wonderful Tim Gu. He said that a lot of the commands that we're going to talk about, if you just type Git Status, it'll tell you what you can do. So you see in this picture down here, we have like four commands that it's telling us, like, oh, like use git push to publish your local commits, etc. So these are all going to be commands that we're going to talk about, but it's really important that you don't need to memorize all of these, because a lot of times Git will tell you what to do, and Git Status is a very, very helpful tool to do that. Okay, so kind of the first thing we want to talk about, whenever you start, you want to use Git, and all of these commands we'll use in like a demo. So don't worry if they don't stick the first time. So Git init we use when we just want to create a new repository. And a repository is pretty much a, you can think of it like a box that holds all of kind of Git's data. So something has to like remember like what each commit is, and kind of like it's the information that tracks the history of your like snapshots. So Git just makes like an empty thing here. Git init. So once we create a repository, right, we kind of have set up our box. You'll want to start developing, right? So you'll start writing up files, and when you make changes, you want to tell Git that like which changes do you intend to commit. And committing, you can think of that kind of like saving, right? So you add different changes for Git add. So in this picture down here, you can think of it like this. So we made some amount of progress in our project. So we have like, let's say it's a it's a web page, and we made a first commit, we added a home page, and then we have like a menu bar. And now I'm down here, and like just on my computer, right, I'm like, oh, there's a bug with a menu bar. So I fix it. And that's a change, right? So you use git add to say, okay, once I'm like moving kind of to commit this change, you use git add to kind of move it from like where your local changes are. And you say, oh, well, git, I want to, this is a change that I intend to commit. So stinky here can be some other change. Maybe it's something you're not ready to commit, it's not done. So the cool thing about git add is you don't have to add everything. Like when you make a commit and you say like, git, I want you to kind of progress, you don't have to use all of your changes. Okay, so then we have git commit, right? I've been saying this word a lot. You've been hearing commit. So effectively, you see we have our menu bar fix here in changes to commit. And we're saying, okay, this is done. So I'm ready to actually commit this new file. Or actually commit this fix. So git commit allows you to create a new little circle like on your timeline. And it puts those new changes inside of this new commit. So here you see that now we have a new commit called fix menu bar bug. Okay. So before we start with like a short kind of a demo of like the basics, I think someone has a question. They say, if you git init a local repository and push changes without attaching your repo to GitHub or whatever, would these push changes be stored in a separate local space from local commits? We'll talk more using about like stuff like, you get in a local repository and pushing changes generally means that you have like a, do you mean commit when you say push versus commit essentially? Okay. We'll talk about this more later, but the gist is that like you can think of push like a level above commits. So when you'll create commits, and you can kind of do this without pushing anything. All push does is say like, oh, I want to take this kind of stuff that I already did, and literally just, you're not creating a new commit or anything with push. You're kind of just taking something and then moving it onto something like GitHub or GitLab or whatever. And we'll go more over that, so don't worry. Okay, so a quick demo. I'm going to switch over to a terminal. Can you see that or no? Can everyone see my terminal?
Yes, we can see it. Can you make the font bigger?
Yes. Okay. Okay, so quick demo. I'm going to create a new project. So we go, I'll just make it like, so here I'm on my desktop right now. So I can make a new directory, and like a directory is like a folder for those who don't know. I'll just call it like project. And then we'll go to project. And then we can use the first command, right? So we had the first thing we do, we have git init, right? So we want to initialize a Git repository in this new folder that we just created. So we can say git init, and it says empty, initialize empty Git repository in this folder of mine. Great. Okay, so once we do that, we can make a commit, right? So let's say I'm working on like some math program. So I'll use Python. It doesn't really matter. You don't need to know Python to understand this code. So don't worry about that at all. But effectively, we're just going to like make a file, right? So you can use any text editor you want. Right now, I'm using Vim because Tim is holding me captive and is forcing me to use Vim. Just kidding. Okay, so we made a file. It's called math.py. And I'm just gonna like make a quick function, right? So this can really be anything. I'm gonna make an arbitrary function. It's gonna be just an add function. It just adds 2 numbers. It's all it does. Great. Okay. So in Vim, right, I'll hit escape :WQ. And then you can see we now have a new file called math.py. Okay, so now you're thinking like, oh, wasn't the next step was to add our math file, right? If we want to put our math file in our Git repository, we have 2 more steps. The first is to add that file, and this is what we call staging. The second is to commit it. But what if I like forgot all of the commands, right? Well, we can just say git status, and it'll tell us there are no commits yet because it's a new repository. And it'll say there's some untracked files. And it'll say use git add file to include in what will be committed. So that's great because this is actually exactly what we want. So we actually don't need to memorize that command. And we just say git add in the file, which is math.py. Okay, great. So if you do git status again, you see we have changes to be committed. It tells us if we want to unstage it. That's how we do that, which is pretty useful. So now that we have this file, it's a new file, it's green. This means it's ready to be committed. So we can say git commit. And that will open up your favorite text editor, which probably will be Vim. And effectively what it's asking you to do here is to enter a commit message for your changes. So I will just put in something like initial commit. And then escape :WQ to save this file. And now we have a new commit. So that is great. So if we say git log, which is, we'll talk about git log more, so no worries. You can just see this commit. So that's like a very brief overview of kind of like the very, very like basics. So yes, and then we'll repeat this too at some point. Okay, so we had git add, we had git commit, and hopefully you might see you might be able to see kind of what's happening here, right? So we initialized repository, we added our changes, and then we added like a new bubble. We added a new circle for our commit. Okay, so if that was the only thing you can do, Git would kind of be lame. What kind of is cool about Git is this concept called branching. Okay, so, you know, many people might ask the question, well, what is a branch? When I was first learning Git, I didn't understand this at all. I used to be in cyber, and ACM cyber, and they were like, oh, you can just make a branch for that change. And I was like, I don't know what this means. Like, what, you're talking about trees now? So let me try to offer a brief explanation. So if you come from the wonderful land of Smallberg and C++, I will give you this explanation. I will say a branch is like a pointer to a commit. When you make a commit, when you're on a branch, that pointer will also move to the new commit that you created. So you can think of it like keeping track of a certain path that you're taking. And then when you make a new commit and you kind of forge that path a little bit farther, that branch, that the pointer will follow. For those of you who don't love the wonderful language of C++, I say that super sarcastically because it's not a wonderful language. I have another explanation. So you can kind of think of a branch like a bookmark, except it's in a choose your own adventure book. So let's say you have you and your friend and you're reading a choose your own adventure book at the same time. And each of you, you read a little bit and then you place your bookmark in the next spot. The wonderful thing about having these bookmarks is that me and my friend can read the choose your own adventure book at the same time. And when I read a little bit more, it won't affect my friend because they'll just go to their bookmark. So, you know, I'll read some, I'll move my bookmark forward, but not my friend's. And what's cool about this is that you can choose different paths and you can kind of read at different paces. Branches allow you to develop in a similar manner as that, where I can work on something different than maybe my team. And even though we're working on the same project at the same time, we can kind of do our own thing. And their changes won't affect me, and my changes won't affect them, because we're kind of on two different alternate timelines at that point. So if we go actually back, that is this concept here of like, you have one timeline kind of going, and then you have like another one. And you can think of these as like two outcomes in your choose your own adventure book. Wonderful. Okay, so we went over this a little bit. Oh, we have a question. Which ways do the arrows point? Oh, that's a really good question. That is an awesome question, because I never really said this explicitly, but the arrows are pointing to the left. So in this one in particular, you see they're kind of pointing against the flow of time. And the reason for this is actually that in Git, like when you have your kind of how it's stored, this graph, when I make a new commit, that commit will kind of have an arrow going to the previous one. It will be like, this is my parent, and it points to it. So like if the very left commit is your first commit, and then time kind of goes to the right, then each of them, yes. So each of them will progress kind of like you'll make new commits and they'll appear on the right. And then each new commit will point at its parent, at the commit that kind of it came from. So that's a really good question. The arrows point to the left. And then like in this diagram, you can imagine like time flowing to the right. Okay, great. Awesome question. So then, well, why do we use branches? Kind of like we said, it lets developers create a path of development that won't affect other teams that aren't on their branch. Okay. So we'll talk about a few kind of commands for like branching, right? And like you can, I wouldn't try to memorize commands. The purpose of this is kind of to show you like in the internal structure of Git, what is this command doing? How is it changing the diagram like of how Git views your project? So the first command we have is Git Branch. And effectively what we use this for is you say Git Branch and then any name, whatever you want to name a new branch, and it'll create a new branch. It's like kind of making another bookmark for your book. And that will point to the commit that you're currently on, which is indicated by head. So we'll talk a little bit more about head, but a brief explanation is that head kind of represents what you're, where you kind of currently are. Like the purpose of head is to give you an idea of kind of within like the whole Git timeline, where like where are you, for the lack of a better word or way of saying this. And we'll get a better, in the demo, we'll get a better feeling of kind of what this means. So here you see first head pointed to master, and then we created a new branch called a menu bar that pointed to the same place that head pointed. So it's like now you have two bookmarks on the same page. Okay, so now this command goes by two names. One is git switch, which I think is the better name. The old name for it is git checkout. So what this command will do is it takes kind of your head pointer of like where you are and switches it to a new branch. So if I want to say git switch menu bar, it will change kind of where I am from master to menu bar. And the kind of cool thing about this is that even if these two branches point to a different place, this will work. It'll actually change your files. So when you do this command, if you switch to a branch that maybe is way ahead of you, then your files will change, they'll be updated. And I do believe, so someone asks, does git switch have the same options as git checkout? I believe it does. I believe it does have the same options. So it like in some cases, like you'll see, yeah, and it is new. Yeah. Cool. Thank you, Tim. Yeah, so the functionality is the same, but I think some syntax has changed. I think git checkout still works though. So yeah. Okay. Next thing, we have Git Merge. So Git Merge, effectively, you can think of it like kind of the opposite of branching. You know, there comes a point where you worked on a feature or something, and then it's done. You'll kind of want these timelines to come and converge. So when we do, if let's say we're in master and we say git merge and then menu bar, all of the changes from menu bar will now be associated. They'll be kind of moved into master, and all of these changes and like will be reflected in this new commit. Okay, last one. You don't really need to know this one as much. This one's sort of a bonus. So git rebase, you can think of it like it'll take all of the commits from your branch and then kind of scoots them backwards. So effectively, if you think of like, you see this menu bar branch and you say, oh, it separated from master at this commit here. If you use git rebase and you say git rebase and menu bar onto master, it kind of moves this point like over to this last commit where master points. So you go from this kind of graph to this one. where you have add menu bar is now pointing to remove vulnerable.js dependency instead of originally it was add basic homepage. Okay. All right. So let me really quickly update myself on what people are asking. I'm unsure. Someone says this is interesting. The way you're talking about branches makes it sound like it would be great to keep track of progress in a video game, where you want to try out stuff but not to compromise everything. Has anyone used it like this? I've never heard of someone using Git like that. But I guess if you made your Git repository, like you made a Git repository where all of your game save files were, you could do that. And then one additional question is, what if there are conflicts when rebasing? I think you end up I think you still get the Git will tell you, it'll say that there's a conflict and the rebase will fail. I believe. Okay. So here's just a last little dump of commands. We already talked about Git Status. I'm mentioning it twice because it's very useful. So Git Status shows the differences between the head commit, which is usually the latest one, and your current files. Git log is the one that I used in our demo. All this does is it shows the commit logs. So you can think of that like where you can see the commit that you're kind of at, and then all of the ones before it. It's really useful if you want to see kind of the history. You can add the -- graph flag, and it adds like a cute little visual. And then Git Branch without any names will list the existing branches. So if I did that in this repository, if I said Git Branch, you'll notice there's only one, and I'm currently on it, and that is master. Alrighty. Oh, there's a few more. Let me quickly take a peek at the. Okay. All right.
Wait, there was that. I don't know if you've touched on this question, but where in memory are the file backups stored? There's some answers in the chat, but if you want to talk about that more too.
Yeah, I will talk about that. Let's see. I don't know what's a better way to display this. So a lot of computers have these like hidden files. And even like if I wanted to say, do I show them in Finder? I guess this is a good way of finding out. Oh, great. Okay. So here's the project folder that I was in my terminal. Here's our math.py file. And then you see this weird .git folder. This is where that's all stored. It's hidden. So most files with the dot in front of them are hidden files. So you kind of have to do a little bit of work to see them. But all of the Git stuff you see, like we have a head file, is stored in here. Does that answer the question? I think. Hopefully it does. But it's in this folder, right? I don't know if I can make this any bigger or not. Right here. Okay, so just a few useful kind of undo commands. Git's really cool, right? If you make some mistakes, usually you can reverse them. It's really hard to actually lose data with the Git. So the first thing is git commit -- amend. If you make a typo in a commit message, you can change it, which is really nice. And then you can also use it to, and I believe that the command changes a little bit, but you can use this to change like what files should have been staged for that commit. So that's pretty useful. We have git restore -- staged file, which unstages a file. So if we did git add on something that we didn't want to, we can use this command to change it back. Another command that does this is git reset head and then file. So that's really cool. I'm actually not going to read these commands out loud because most of them it'll tell you about them in Git Status. Like these restore ones, Git Status will tell you, so you don't have to memorize them. So we have this one, you can discard a file's changes. So if you're like, oh, like I don't care about anything about this file that like I typed in since like the last commit, you can restore that file to the state of the last commit. It's kind of like if you're playing a video game and you saved some point and then something really bad happened and you just kind of reset the game. And now you're at your save point instead of wherever bad place you were before. So that's really cool. And then here's git revert. It kind of does what it sounds like. So you give it a commit hash, which is, you can see it in git log. It's like you can think of a commit hash like an ID. Like, so you can think of this as like a commit ID. And effectively what it will do is create a new commit that undoes the commit that you gave the ID for. So that's really nice. And then, yeah, so if we say, if you want to know where the hash is, you just git log to this big fat thing right here. That is the commit hash. It's literally just an ID, effectively, for the commit. All right. So I always kind of learn better through actually doing stuff. So now that we kind of like wet our feet to the idea, I would like to do a short demo. So first, before, if any of you are unsure about kind of a Git, or like you don't have it installed, or maybe you want to follow along, here are some instructions on installing Git. So you can do that. So for Mac, I usually use Homebrew to install Git. Linux, you know what to do. It's pretty hard to write comprehensive instructions for installing anything on Linux. And then Windows, you can go to this link and there should be a download thing there. A note, there are some new commands that I'll touch on a little bit. I think mostly it's just git switch, which is for this tutorial is pretty much the same as git checkout. So if you ever wondered how to update Git, there are instructions right up here. On Mac, it's really easy. You just kind of do brew upgrade Git. On Windows, the easiness depends on the version of Git that you have installed, but you can always just kind of re-download it from the link and just download the latest version. So I believe the slide after this, I'm gonna like skip ahead a slide, but I'll come back to this if anyone needs it. Okay, yeah. So I'm gonna leave some time for this if anybody just needs these instructions, if anyone wants to follow along. And I'm gonna leave these up here like probably for 10-ish minutes, and we'll take kind of like a little stop, and I'll resume at 6:53 p.m. I will start talking again. 6:53. Other than that, if you want to install Git, if you don't have it, I'll leave these instructions up here for you. I'm going to add a note to the slide though really quickly. Just about the time. Okay. Okay, we have, this might be a dumb question, which is probably not, but what do we do for Linux? Just init. Oh, is this for, so you're trying to install Git on Linux? Okay, so I think usually for Linux, oh, look, I think, yeah, we got some answers in the chat. Yeah, sudo apt-get usually works, but but for Linux, it depends on the distribution, which is kind of why I omitted the instructions. It's because it'd probably be its own slide. Yeah, if you want to test if Git is already installed, you could try opening your terminal and running git -- version. And then if that command succeeds, it should give you a version number if you're unsure if you have it installed. It's funny because usually at when we do these workshops live, as in like Coval 227 or like a room on campus, whenever we do stuff like this, when we're having people install things, it's like there's like a murmur, you know. It's like you have people kind of talking, and like sometimes people have problems, and there's like this kind of ambient conversation going on. But because it's on Zoom, it's just dead silent, which is a interesting feeling. It's definitely an interesting dynamic. Classes have changed a lot too. It's weird. It's all weird. Yeah. Thank you for the ambient voice. And yeah, also for your Mac users, Homebrew is sometimes likes to take its time. It updates a lot. So if it takes a little bit of time for you to install, this is normal. So don't be worried about that. Oh. I don't want to stop. I'm trying to think. So with professors who have been doing classes online, I think the biggest thing was using like a whiteboard or drawing tablet of some sort, especially for like math-based classes. Is probably the best things that they've done. So. We're getting some people finishing up. We have about 3 more minutes, so don't worry if it's not completely done yet. Yeah, breakout rooms are very hit or miss. Someone says about Zoom. I agree. It seems like a really good feature and concept, but when you have a bunch of people who don't really know each other and then they're just kind of thrown in a breakout room, what normally happens for me is no one turns on their video, no one even turns on their mic, and it's just like a group chat for like a minute. I don't think those have been the most effective for conversation, for sure. Yeah, people are just shy. It's like that's the biggest thing. Oh yeah, for those who don't know, a breakout room is this Zoom feature that pretty much partitions a meeting, and it kind of creates little sub bubbles of of mini meetings, and you divide the people in the meeting into different like rooms. So if you have a meeting of 30 people, you can create 6 breakout rooms of 5 people each, and then they're in their own like isolated Zoom meeting. And then when you want to bring them back into the main group, you can do that. So a lot of teachers have been trying to use this to replicate the like, talk to your partner about the, I don't know, Odyssey or whatever. And it hasn't worked super well, in my opinion. Alrighty. Is there anyone who's still struggling on installation stuff, just to get a feel of the, for lack of a better word, room? What does it look like? Because I'm going to continue in about half a minute, unless somebody, if you still have like people installing. Really timely person. All righty. So assuming that is complete, I'm gonna move on. So when you first set up Git, like I said before, like Git keeps track of a few things, and 3 of them are what was committed, what changes were made, who did those changes, and when were those changes done. So when you first set up Git, you kind of have to give it that who part, and you use these 2 commands to do it. So you have git config -- global, and you have user.name followed by your name, and then another command with user.email followed by your email. These commands are used to identify you on your commits. So when people are looking through the logs, or they're trying to figure out like who maybe wrote a certain feature, they can identify you, and then if they have questions or bugs, you know, you can work that out together. So yes, I already have this done, so I'll leave this up, but you only have to do this once for your like installation, I believe. Alrighty. So after you do this initial configuration, you can kind of you can start creating a repository and stuff. So this is unneeded. This is kind of where we get into like the meat of like the demo. So I'm going to actually start from scratch. We already like made a Git repository, but because some people did not have Git installed when I did that, we're going to do it again because repetition kind of helps with getting the flow of this. So I'm going to go and head to my command line here, and we're going to not do Git anything. We're going to get out of here. So I'll just navigate to a new folder. So I went out of the current folder I was in that had my old project, and I'll just make a new directory called, I don't know, new project. Go to that one. Okay. So like before, we start with, let me pull up the thing here. We start with git init after we did our configuration. And we get the same thing that we had last time. So it's an initialized empty Git repository, and it gives us our empty box. Like before, we can actually see the kind of repository files, which is pretty cool. So we had talked about this a little bit before. Okay. So after we're done doing that, we can kind of get started. Let's just say I'm going to make the kind of the same file again. So I'm going to just open up my favorite text editor and create a new file. And it's also going to be called math.py because I'm uncreative. So this is math.py. And we're going to make a function, and it's going to be called cool add. Why is it so cool, does Tim say? Oh, because it adds not 2 things, but 3 of them. Wow. So now we have a function, it adds 3 numbers because more is always better. Okay. And then that is all we'll do. So just like before, we go out of Vim, we save and quit. If we look in here, we see our new file. So then what do we do next? Well, we have to say, okay, we create this new file. Well, I don't remember. What do we do? Git tell me. Git add, right? We have to stage our files to say what will be committed. So I say, please add math.py to the stuff that will be committed. Okay. After that, you should see this in green. So yes. Now we can commit it and feel safe to do that. So fun thing with commit, if I don't want to open up a text editor when I do git commit, I can say git commit -m and then a commit message. So I can say add like math.py or something like that. And then it'll just do the commit right away instead of opening a text editor, which is really nice. All right. So after we do that, we finished, we initialized repository, added the file, and then committed it. So if we do git log, say git, I want you to show me the commit logs, we should have one commit for add math.py. Alrighty. So that's kind of like what we did, but then we also talked about branching. Do you remember? So I'm going to roll back to the slides because I believe I have slides for this. Aha, yes. So we have some stuff about, I don't know if no, I did not. So I have a quick scenario here, right? And we're gonna do this scenario. It's a scenario between two developers. I've named one Kozilek and I named the other Emrakul. And they are developers at the same company working on the same project. So just to give you an overview of how this will end up working is the first day, Kozilek, from the code that we had before, from this screen, he's going to add a change to math.py, or he's going to make a new branch first called subtraction. And then he's going to change math.py in that branch and commit that change. Okay. Then Emrakul will do the same. She'll make a branch and she'll push a commit to it. And then they'll both try to merge their branches into master. Okay. So that's kind of a quick overview. So you kind of know the general gist of what is going on. So let's see what happens. In doing this, I was using Vim before, but I really want to use VS Code right now. So I'm going to do that. This is my real favorite text editor. It should open up, hold on. Oh yeah, I'm gonna do some Mac things really quickly. So I can get this in where I want it to be. Okay, can everyone see this? You should be able to see my text editor on one side, and then my terminal on the other side. I can't see the chat. So let me just take a looky. Looks like no one's having problems. Shouldn't say ew. Gross, Tim. Mean to me. Okay. Real quick, I'm actually gonna make a quick change because let me set these windows up really quickly. I'm gonna do it this way because I like this way better. Okay, and then we're gonna open a new folder, and that's gonna be the one that I made. So I think I just made it on the desktop. Oh, it's this one. It's already open. It might be. Ah, great. Okay, I'm just gonna have this open here. And this is where we'll make our changes. So yes. Okay, day one, right? So now we're Kozilek and we want to make a subtraction function. So like a good developer, we're gonna make a new branch. And how we do that, I'm gonna give this one a little bit more space, is Git Branch, and then a branch name. I'll call it subtraction. Oh. Okay. So make this a little bit smaller. Then if we say Git Branch, to say what branches we have a master branch and a subtraction branch. So then we're going to want to switch to our new branch. So we say git switch subtraction. And then we get this nice little message that we switched branches properly. Awesome. Okay, so now that we are on the branch we want to be on, we can make the change we want. So Kozilek wanted to add a subtraction function. That's pretty easy. You can just say def sub. It takes in two numbers and returns the difference. Great. Wow. And after a long day of hard work, Kozilek is now ready to commit his 2 lines of code that he worked very hard on. So he's gonna save his file and then say Git Status. And you see that, we have a change and we want to add it. So git add math.py. And then we want to commit that change. So git commit, and then just say add subtraction or subfunction. Function. Awesome. Alrighty. So now if we do git log, you see we have 2 commits now. We have our new subtraction branch and our add subfunction commit. And then master we left in the dust, right? We made a new commit without master because we were on subtraction. All right, so normally this feature is done, right? So we'd be like, oh, we should merge it into master, right? Our subfunction is done, but that's not how it works at big companies. Kozilek must wait until quality assurance, the quality assurance department approves of his changes. So Kozilek will go home for the day with his branch waiting to be merged. Awesome. So what happened? Here's what happened. We had Kozilek created a new branch called subtraction, and then created a new commit for the add subtraction function. And that's all, right? So you made a new branch and then put a commit on that branch. Great. Day 2. So now, Emrakul comes into work, right? Emrakul is our other person. And Emrakul has a little bit of a harder task than Kozilek did. So Emrakul gets the task of write a function called sumRange that takes in 2 numbers and then returns the sum of those 2 numbers plus all of the integers between those 2 numbers, right? So effectively, if we have any math people in the audience, this is saying it's the sum of an arithmetic sequence, right? That increments by 1. That is Emrakul's task. It's not too hard. So don't worry, it's like a line. Okay, well, so first we're now Emrakul, so we're not going to be on Kozilek's branch, right? So let's go back to master. So there's an interesting thing here. I want you to pay attention to my VS Code when I switch to master. So I'm going to do this command. And you see that Kozilek's function went away. And that's one of the things about switching between branches, is that we went back in time a little bit, almost, where because Kozilek's changes are only on his branch, when we switch off of that branch, we don't see those changes anymore, which, it makes sense because they're not on the main branch, they're on his branch. Okay, so we're going to have Emrakul make her own branch. And this is just like before. So we say Git Branch. Oh, yeah. And then and we're going to call it some range. And then we're going to switch to that branch. Ooh, 2 options. So an interesting thing is you could have used, there's 2 other commands that you can use to do those 2 commands in like one swoop. One is git checkout -b. The other one is git switch -c, I think. So there's like a lot of shortcuts. So I could have done, I think, git switch -c and then the name of the branch. And that should have created a new branch and then switched to it. Okay, so now that we're in our new branch, we're going to add our feature. And it is a function called SumRange. Look at this. And we're mathematicians, so we're going to make this convoluted equation. The contents of this equation don't really matter. It is this long thing. Honestly, if you're following along, you can kind of just return 5 and it doesn't really matter. This is just the sum of an inclusive arithmetic sequence that starts at X and ends at Y. This big, gross equation here. Alrighty. So we save that. And then what do we do, right? Well, we need to add and commit our changes. And now the interesting thing is that there are a lot of Git shortcuts. One of them is the following. So we have Git Commit, and then if you tack on after Git Commit -a, it adds any files that have been modified or deleted. So this is really useful if you don't want to have to do git add every single time, because we're programmers and sometimes we're lazy. So we say git commit -a, hit return. Just so we're sane, you see here it says changes to be committed and it says we modified math.py. So all of that looks normal. Then I will say add some range function. The zoom bar has obscured my vision. Some range function. Y'all. Yeet. We did it. Good job, us. Zoom is being mean to me and putting windows in the way of my things. Okay. So we commit our changes, and you can see now that we if you do git log, we see this new commit, and more importantly, we don't see causal-x commit, which is great. Okay, and then once again, we did our commit, mission accomplished. We now have to wait for quality assurance to approve it, approve our changes so they can be pulled into master. Okay, day 2 has ended. Emrakul went home. What happened? So this is where we left off. We had Emrakul's branch, or causal-x branch was created already. Emrakul was on master and created a new branch called SumRange and pushed a commit to it. Or pushed a commit. They didn't push anything. He made a commit. Oop, that's for later. Spoilers. Okay, so now we have kind of 2 timelines going on. So in our like choose your own adventure book analogy, we have Kozilek and Emrakul have kind of chosen different adventures, and their bookmarks are on kind of different timelines. Alrighty, so they got good sleep, and now it is day 3. So Q quality assurance got back to both Kozilek and Emrakul and said, your changes are good to go, right? Your changes are both good to go. You may merge them. So Kozilek comes into work about 30 minutes earlier than Emrakul. And he says, oh, great. He's so excited, you know, he gets to release a function he worked really hard on. So he's gonna switch to master. Great. And then use the merge command to merge his branch into master. So what he's gonna say is he's gonna say git merge and then his branch name, subtraction. And what this is saying is that I'm on master right now. So Git, I would like you to merge the subtraction branch into my current branch, which is master. Hit return. Awesome. So you can see now that we are on master. So if I say git branch, right? We are on master, and we can see that our subtraction change has been merged in. So if we say git log, we see that master now includes our sub function. Awesome. Okay, Emrakul comes in about 30 minutes later. Emrakul is like, you know, okay, I gotta go merge my commit. So Emrakul, who is on master, right, will say, okay, well, I'll just do the same. I'll do the same thing. We say git merge, and then we say sum range, which is the name of the branch. Oh no, something went wrong. So let's try to dissect what happened here. So we have, I'm gonna make this one smaller. Okay, we have auto merging math.py, and it says conflict. Merge conflicts in math.py, automatic merge failed. Fix conflicts and then commit the result. So what happened, right? I'm gonna quickly actually move over here and show you this. So effectively, in this picture at the very right, we kind of had two timelines try to go into one. And the problem is that there were changes that don't really work with each other. And it caused what's called a merge conflict. So if you look here, Git once again kind of helps you out. So it says, listen, I don't want to ruin your work. There are some changes that you made that I don't really know how to fit them together. So what I'm going to do is I'm going to put both of them here, right? So here's Kozilek's change, and here's Emrakul's change. And what Git is saying is that I don't know how to combine these. You put two new things in the same spot. So like, which one's supposed to go first? There's no way to know. So what I'm going to do is I'm just going to put them both here and say you do it. You put which one you want first, and then just tell me when you've fixed it. So let's do that, right? So how you do it is you can open it up in whatever your favorite text editor is, right? So let's say I opened the same file. I opened it in Vim, right? You see this kind of same thing. Now, this merge conflict is not super bad, right? Because we know, like I know, I want both of these functions. There's no like real intricacy here. So what you can do is just kind of delete the stuff that Git added for you. And then I'm gonna add, so you just delete all of this stuff and save it. And then after you do that, well, I don't know what to do. So what's our favorite command? Git status. Wow. So it says unmerged paths, means that the merge failed, right? And it says use git add file to mark resolution. So yeah, this is what we want, right? Because I fixed it, right? I said, oh, this is how I want this to look. So Git, I know you couldn't do it, but now I did it for you. And I want these functions to be here like we put them here. So we did that, we fixed it, and then we can say git add math.py. And then we just say git commit. And this is saying like, Git, I fixed the merge conflict. You can finish doing the merge. Okay, and it gets really nice to us and it says, oh, okay, I know you had a merge conflict, so I'm going to make this commit message for you because I always have a lot of trouble coming up with commit message names. So yeah, then we can say :WQ. And that should fix it. So if we say git log, we can see that now we have this commit here. And then we also see that on master, which is the branch we're currently on, we have all of the changes. We have Kozilek's change and we have Emrakul's change. And that's the goal, right? So I know the first time when I was first learning Git and I got a merge conflict, I literally would just always have to hand the laptop to somebody else and be like, I don't know what this is. But it's not actually too, it looks more intimidating than it really is. All it's saying is saying, I have two changes for you. I couldn't mix them together. So just, I would like you to do it manually. So yeah. So one question I just got was, when you list the files in your project folder, are branches being shown? And I think if you mean like with the ls command or the dir or whatever it is on Windows, no, the answer is no. So let me see if I can, I'm just gonna use a normal ls command because it's a little hard to see. We just see our math file. The branches like are technically stored in this kind of .git file somewhere, but branches are not files themselves. Branches are like little pieces of data, kind of like a pointer in C++ or just like it's like a little kind of variable of sorts. Okay, so it's good etiquette once you are done with a branch and you merged it. Usually, so if you say git branch, you see subtraction, you see sum range, and I'm a level with you. We're never going to use those branches ever again. And we don't really want them around anymore because we're done with them. So usually you want to remove the branch after you're done merging it. So we can say git branch and then -d and then the name of a branch. Oop, it's being mean. And then you'll see deleted branch subtraction. And we can do the same thing for the other branch that Emrakul did. So we say git branch, sum range. Oh, yeah. Sum range does not like me. Oh, did I spell it wrong? I did. Oh yeah. Hold on. Git. Sorry, my terminal's being a little mean to me. Aha, got him. Okay, so now if we say git branch again, we have just the master branch. So git branch -d for delete, and then the name of a branch will delete that branch. Okay, so can you delete master? You know what? I've never tried because the thought terrifies me. Tim says no. Tim Goose says no, you cannot delete master. It doesn't really make sense to delete master. So I wouldn't think to delete it, but you know, you think so? Oh yeah. If anyone can't see, like, here's like the upper part of my terminal. Yeah. Alrighty. Oh yeah, my terminal's being a little bit buggy. The command for deleting a branch, oops, is it's just git branch -d and then a branch name. My terminal's being real mean to me and omitting letters from like the display. So for some people, it might have been hard to see. I apologize for that. So just to unpack this a little bit, we had two merges that happened. First, Kozilek merged his branch, and that worked. And when Kozilek merged his branch, let me get my pointer. We had master, like all the changes from the subtraction branch were incorporated into master. And this was kind of an interesting merge because normally a merge will create a special merge commit, and it's an additional commit that the merge creates. But I don't want to get too down in the weeds. Effectively, sometimes Git is smart and realizes there are cases you don't need a merge commit. And this was one of those cases. So it just kind of updated master to include subtractions change without creating a new commit. However, when Emrakul merged her work, there was an additional commit. So we had kind of two timelines, right? We had the subtraction function and the sum range function were both added, and then those changes were kind of combined to create a new commit on master. We had a merge conflict, but we fixed it, and then everything all is well. And we have our kind of stuff here. We have our kind of commits all lined up. One nice thing I do want to mention really quickly. So I've been using git log a lot. There's a flag you can add called --graph. And it kind of gives you like a little bit of like this little picture, which some people might find useful. Right now it looks a little wonky because my terminal, but it kind of tries to show you this diagram that's on the slides, which is useful. Okay. Okay, one last thing I wanted to talk about was I talked a lot about Git and not a lot about GitHub. Right? One of the coolest things about Git is that you can collaborate with other people. And that's really useful. So I'm going to talk about that. So if you want to have your Git repository to like be accessed by multiple people, usually you use something like GitHub. And I actually don't have slides for this because I'm silly and mean. So that's if you're looking at the README, you can see all this stuff down after the merge conflict stuff. So right here, right? So I'll show you. So right now I'm on GitHub, but I'm going to open another tab and go to GitHub. So usually you'll sign up for account, right? So if I am signed out, you'll see a page like this, and you just go and create an account, and then say like sign up for GitHub. I've already done that because you just saw I signed in. So this is the page that I see. Okay. So now we're saying, okay, I want to put my math file, my cool like math Python file. I want to go and I want to put it on GitHub. So the first thing I need to do is create a kind of spot on GitHub for my repository to go. And you just do that with this new button. It's very green and it looks like it's what we want. So let's click on it. And then you just fill out some information, right? The only important thing is really the repository name. I'll just name it like project. I don't know. I think the repo name was project 2 on my thing. We don't need a description. It's gonna be public. I don't care. And then you hit this create repository button. Yay. Okay, great. So it gives you a bunch of instructions here. But let's just say like, oh, I don't know, I'm not really super smart and I didn't read any of this. I don't know. And I just kind of like, I'm in my repository and I'm like, oh great, you know, it's like we can push our commits, right? We can take all of our commits and we can push them onto GitHub. And I know the command to do that is git push, right? That's how you push your changes to GitHub. It'll give you an error. But Git will give you a useful error. It'll say, well, you didn't tell me where to push it, right? There's no configured push destination. So it says either specify a URL from the command line or configure a remote repository. So I'm like, okay, well, I'll just do that. So we have this command here. So we can say git remote add, and then a name, right? This is usually origin. I think that's the default name for a repository. And then the URL, you're like, well, what URL? So it's not this URL, it's this URL. So you can copy, this will show up, will be something different for you if you're following along. And you just pop that in here and then it probably should work. Yes, hooray. So now we said git, this is where I want you to push, right? Okay, so now let's try doing that second command. So we say git push and then the name, which we said the name was origin by default. Oh no, we got another error, but we got another helpful error. So it says the current branch master has no upstream branch. It says to push the current branch and set the remote as upstream, use this command. So that's really useful because it kind of just tells us what to do. So we can actually just kind of yoink this command here and paste it, and it should work. So we just kind of copied this git push -- set upstream origin master, and then plop that down in here, and then it successfully pushed. So what's the moral of the story? The moral is you don't need to memorize commands. You might need to memorize like git push, and then it's really, Git will kind of give you hints on most of the rest of it. Okay, so if we refresh this page, we should see, wow, everything's all set up, right? So we have our math.py file. It has all of our stuff in it. So that's great, mission succeeded. Okay, so what if somebody makes a change that I want, right? Because the coolest thing, like I said, it's a two-way communication. So let's say somebody else makes a change to our repository. I'm going to simulate that by just directly making that change on GitHub. So this is I'll move back here. This little pencil icon, you can kind of just edit files right in GitHub. So we'll add a new function. What will we call this function? Actually, I'm not sure if I like put like a, so we'll just say def, that's a lame, that's fine. It's a multiplication function. We're sticking with the theme. It just returns the product of these two things. So some other person says, okay, I'm gonna make a multiplication function and add it to this file. So just like normal, you commit this change. So I'll say, so this is just literally a new way of doing the same thing we did before. So we'll commit this name, we'll say add math, or not math, mult function. Awesome. Then we commit directly to master. That's fine. Sometimes you don't do that, but in this is an example in which we can. Okay, now we added it. Awesome. So that means, right, that someone made a change, but I don't have it yet. So if you look at like my VS code, I don't have that multiplication function. So the question that you would subsequently ask is, well, how do I get that function? So I don't think Git Status actually tells us anything here. YouTube doesn't want. So you can kind of think of this as two things. You can push and then you can pull, and they are opposites. So what we do, we to get stuff onto GitHub, we pushed it. And to get stuff off of GitHub or from GitHub to us, we pull. So we can say git pull, and we get our multiplication function. So you see it updated our changes. So that's pretty cool. An additional thing I do want to tell you guys about, there is a thing called, so what is git pull doing? Okay, it's taking the changes, it's taking kind of the metadata from GitHub and loading them onto your computer, and then it's doing a merge, right? So it takes those changes from GitHub and merges them with what you currently have. What's up with the thing that can go wrong with merging is merge conflicts. So you can actually get a merge conflict when you pull, and that is sometimes not fun. So there's actually a kind of another thing you can do that's not pull. So let's say if we go back here and we make another change, let's just say, I don't know, pi equals 3.14 up here, something like that. And add pi. Great. Okay, so we committed a change, right? And you can actually, you don't have to pull it. You could say git fetch. And it kind of, Git Fetch does is it does the first half of pull. It just kind of takes that information and like the metadata and kind of loads it onto your local repository. But you notice that it didn't change this file. So it's a little bit of a safer version of Git Pull, which is nice. So if we do Git Status here, you'll see it now knows. It says your branch is behind origin by one commit. So there's one commit that origin has, that GitHub has, that you don't have. And then it says use git pull to update your local branch. So then we just kind of, we can do git pull. That should work. All right. So that is most of the stuff I have to go over. Sorry. Does anyone like that kind of concludes my my spiel, for lack of better words. So if you guys have any questions, I'll stick around and we can talk about it. Other than that, that kind of concludes the workshop. So yeah. So one person asked, do you have a favorite Git command aside from the ones you covered? So it's probably not super unique. And I'm sort of doing this to spite Tim Gu. But my favorite Git command is git stash. Why? Why is it git stash? Because this is fun. So let's say, oops, no, stop it. This is the application I use to make my flowcharts, but we don't need it. So, oh yeah, yes, I will also plug that. Let's say we had a branch, right? We have a new branch and it's called Tim. Okay, and then we switch to Tim. Okay, and we make a change, right? But we're not done with the change. So we are like, oh, we're like almost defining a function, and you're like, oh, okay, def, and then you're saying like milk, potato, but then you like interrupted, and then Tim Gu or Galen, he comes to you and he says, quick, I need you to switch to master and look at this thing. And then I go, oh no, I made changes, but I can't commit this because it's just def milk poto. So what you can do is you can say git stash. So let's say I do try to switch branches, right? If I say git switch master, it should block up. No, it didn't. Oh, because I didn't. Oh, that shouldn't have worked. Interesting. It's for like storing changes temporarily. So a lot of times if you have like uncommitted changes and you don't want to lose them, you can say git stash and then you can do git stash pop to get those changes back once you're like off of master. Unfortunately, for some reason, it's being a little bit odd. So I'm interested to see why that is. But I wonder what it doesn't know. Yeah, it kind of just like makes a temporary commit effectively. But yeah, I think it's useful. Tim thinks it's bad because he doesn't he's I did save. Silly. Is there a way to clear it? Ooh, mean. Like the stash you've saved. I think you can. A lot of times, oh, there we go. Tim to the rescue. Ooh. Hold on. I think my window was focused on Zoom while I was while I attempted to save. So now I have issues. This is fine. This is fine. Yeah. But yeah, git stash. It's really nice. So yeah, one thing that like I guess an extra tip is so I sometimes you kind of get got by not saving. I think because when I was trying to do this, it wasn't working. It might have been because my cursor was focused on chat while I tried to save with something. But I tried to like Command S and it didn't work. And now it's doing this because for other reasons I'm not going to explain. But yeah, git stash. I like it. It's fun. It's also on the README, but I didn't go over it. Yeah. Oh, also, for those of you who are still here, we have a feedback form if you want to fill it out. It is on the last slide. It is this slide. So please fill it out if anyone's still around. Yeah. But thank you guys so much for coming. And you know, it's been oh, don't do that. Don't do that. It's been fun. So. Oh, thanks, Alex. Yeah. So feedback forms in the chat. Fill it out if you want to kind of talk about things you like, things you didn't like, topics that you wish could have gone, we had explained, all that sorts of stuff. So. I've definitely stashed some questionable code in the past. Oh, man. I'm going to stop recording as well. So, all right, forgot how to do that. Aha.